Let us prove the associate property for impulse response representation of discrete time LTI system. The property says that x of n linearly convolved with the result of linear convolution of h1 of n and h2 of n, that is equal to the result of linear convolution of x of n and h of n, that is linearly convolved with the h2 of n. To prove this, let us consider this cascade system. We have two LTI systems here. Impulse response of the first LTI system is h1 of n. Impulse response of this is h2 of n. Output is y of n and input is x of n. Output of the first LTI system, let us denote it as an z of n. Now from this we can write that is y of n equals to z of n, that is linearly convolved with h2 of n, where z of n equals to x of n linearly convolved with h1 of n. Now from the convolution sum formula I can write that y of n equals to summation of k tends from minus infinity to plus infinity z of k into h2 of n minus k. Now let us get z of k from this equation, that is z of k equals to x of k, that is linearly convolved with h1 of k, that is equal to summation of p tends from, instead of k I am using the variable p here because already k is used here. This is k. P tends from minus infinity to plus infinity x of p h1 of k minus p. Instead of n I am using k here, instead of k I am using p here. Okay, then y of n equals to, we can write summation of k tends from minus infinity to plus infinity, where z of k is replaced by this equation, that is summation of p tends from minus infinity to plus infinity x of p h1 of k minus p, and that is multiplied by h2 of n minus k. Let us interchange the order of summation, that is y of n is equal to, first I'll write the summation, the variable p, summation of p tends from minus infinity to plus infinity x of p. Outer summation you take it inside, that is summation of k tends from minus infinity to plus infinity h1 of k minus p h2 of n minus k. Okay, in this equation put k minus p is equal to m. When k tends from minus infinity, m is also minus infinity. When k is equal to minus infinity, m is also minus infinity. Minus infinity minus p will become minus infinity. When k tends to plus infinity, m is plus infinity. From this I can write that is k equals to m plus p. Now the above equation can be written as, it is y of n equals to summation of p tends from minus infinity to plus infinity x of p. Keep this first term as it is. Second summation is where m tends from minus infinity to plus infinity h1 of m h2 of n, where k is replaced by m plus p. Outside minus sign, it will become minus m minus p. Okay, now let us remember this equation. Now you know that h1 of n is cascaded with h2 of n. I can write that h of n is equal to h1 of n, that is linearly convolved with h2 of n. In this equation, put n is equal to n minus p. You can write that h of n minus p equals to h1 of n minus p, that is linearly convolved with h2 of n minus p. that can be written as h of n minus p is equal to summation of m tends from minus infinity to plus infinity h1 of m h2 of n minus p minus m. Instead of n you have n minus p. See, this is same as this complete equation. Now y of n can be written as summation of p tends from minus infinity to plus infinity x of p, this can be written as it is h1 h of n minus p, h of n minus p. This is same as x of n is linearly convolved with h of n. But what is h of n for us? H of n is h1 of n is linearly convolved with h2 of n. Then I can write that y of n equals to x of n that is linearly convolved with h of n, where h of n is h1 of n that is linearly convolved with h2 of n. Okay, this is the proof. Thank you.